Hey everybody, in this video we are going to look at solving equations with rational exponents. Hopefully we all remember that rational exponents are another way of writing radicals. So for example, x to the 3/5, right? Do we all remember that that is the same? That's the index, that's the power, right? We said that's the queen and that's the peasant, and the queen lives inside the castle, x to the third, and the peasant lives outside in the gutter. Okay, I don't make the rules. This is what we learned about medieval times, right? Anyhow, well, I mean, more than just then, huh? So here we have essentially a radical equation, but it's incognito, it's in disguise, it's looking like rational exponents. So sometimes when things don't look like what you're maybe used to seeing and you end up doing operations that are sort of hidden from your brain, you might miss key details. So the first example, A, is going to be a little bit more straightforward and simple. This has a bit to do with the fact that both 3 and 5 are odd. There's no funny business. When you have an even power coming into play, that's when things get a little interesting. So I will probably break this up in 2 videos because I feel like it's better to have 2 short ones, but make sure you watch them in unison, okay? Like watch part A right now and then watch part B next, okay? So how do we get this going? So similar to solving radical equations, we're going to isolate the radical or isolate the expression that's raised to the rational exponent, right? So this is already isolated, so we are good to go. So I'm going to raise both sides to the reciprocal power. I don't need to break this up into multiple steps, okay? So I'm going to raise both sides to the reciprocal power. So I'm just going to rewrite this, and I'll have x to the 3/5, and I'm going to raise that to the 5/3 power. And then it equals, that's really 27, and I will raise that to the 5/3 power as well. But something that I felt like you guys are actually really good at is this 27 over here. We're going to do our swap opportunity, right? What can I swap out this big beefy 27 for something smaller, lighter, raised to a power? And if you said 3 to the third, you are a smart human. So what happens? What's 3/5 times 5/3? So don't tell me 15/15's, you silly. The threes reduce. The threes reduce, the fives reduce, and I'm left with, on the left side, just x. I don't need to worry about any, this is foreshadowing, plus minus when I take a cube root or raise to the 5th power or any of that. Equals, here, the 3 and this are going to cross out because it's really 3 over 1. When you multiply, tops and bottoms can reduce. This is a power of a power. So what's left is 3 to the 5th power. Now, I think most of you guys know that 3 to the 4th power, we've done it enough times that that's 81. So 3 to the 5th power is 80 times 3, 1 times 3, add them together, and what do we get? So x equals 243. And there you have it. Now, if you were trying to test that answer, do I expect you to raise 243 to the 3rd power and then take the 5th root? No, let's not be crazy. If I were doing x to the 3/5, if I was testing this back in and seeing if it's 27, well, 243 is 3 to the 5ths, and you're raising it to the 3/5. Those cross out. I'm left with 3 to the 3rd, and that, yeah, that's 27. We're good. Great. Okay. So that is the end of this example. Maybe I shouldn't have erased all that. That is the end of this example, okay? So what is that? It's less than 5 minutes, but we're good on that. So I'm going to just break it up into a separate part so that that next example can stand on its own, because this guy is the case where you end up getting extra solutions. So if you ever forget, like, oh, what do I do again? Why is it that the answer key is giving me more answers than what I'm finding? Maybe bookmark this one, because you're going to come back to this example over here. This will be your savior. Okay, so that's it for now. Adios. See you in part B.